Welcome to Everything Distributed. Today, we are going to talk about a very fundamental thing in distributed system, how to share data, especially in message passing system, is not as trivial as you think. And the content is based on the materials inside chapter number 4 by the very good book by Martin. So many at the very beginning, we talk about that one way of sending message is to use a TCP/IP framework, and then we have this TCP/IP kind of suite. And at first, we have application layer. For example, we have a web browser, we have this HTTP protocol, and we will use TCP, and then IP layer, and then go down to the physical wire, and wire will send some packet to the other end. We might go through router, go to switch, and then to any other process. But fundamentally, what is the format that we are sending? Because we don't want to think about that it's in an electronic format. We want to kind of have an idea what is something that is being sent through the network channel. And it is actually a sequence of bytes. So usually if you look at the documentation for TCP/IP, then you will see a stream of bytes. Basically, that what the sender or the channel just like feed you tons of bytes, and then they are always incoming, and that's how you should think about that. But in order for your application, for your process to work, you need to have some data, you need to have some data structure. It may be a file, it might be an array, then you might be like some customized data object. So the process of transforming from data object to a sequence of byte, from a sequence of byte to data object, is this idea called encoding and decoding. And usually I think that serialization or even marshalling are much more popular than encoding. However, Martin said that because the term serialization actually is also heavily used in another context in distributed systems, so he personally prefers to use encoding, and we will stick with that term here. And for decoding is kind of the other hand. So from encoding is a data object to a sequence of byte. Decoding is from sequence of byte to data object. And it's also called deserialization or unmarshalling. And there are tons of examples because each of them has a special design. Some of them are tied to a particular language. For example, Java has its own, Python has its own, and Go support like several of them. And then if you are familiar with lots of web app or mobile app, you should be familiar with this JSON file or XML file, and then Go has its own thing called GOP. But like if you want to, or if you really care about performance, then you should look into Protobuf. It's developed by Google. It's claimed to be smaller, faster, and simpler. And in my experience in our project, actually we find that Protobuf actually is much faster than GOP. And that's yeah, so it's a good tool to pick up. And the detail on how exactly to do encoding and then what are the trade-off is beyond the scope. So we'll stop here. But the key idea or the key intuition on how to use this encoding or decoding is that we need to have a schema that describe that how each binary or how each place or sequence of binary match to what. So for example, you need to tell the destination. I say that, hey, I'm going to send 10 bytes. And then the next byte is I specify the sender. The next byte might specify the size of data, so on and so forth. And then there are lots of trade-off of design. And then for this schema, it also tells you how to validate that you receive something correct or that is something that is not corrupted. Because if you think about TCP/IP, or if you think about sending message in general, yeah, there might be some garbage, and then the sender might send you partial result because sender just cross-checks. So you need to have certain way to reconstruct your data, and then make sure that your data is the exact format that you are looking at. And some of the good properties that you want to have when you design the encoding or decoding protocol is that you want to make sure it's compact. If you kind of blow up, then you are sending too much junk. That's not very efficient. Then the schema actually serves a very good purpose of documentation. It tells you that which version of the system you are using, and then when you do this schema changes, you also need to think about like how to do this forward or backward compatibility. And then if you are using a statistically type of programming language, and then this schema actually help you to do type checking and compile time, because if the data is in correct format, when you send something, then you will find that the schema is mismatched, then you know something is wrong. Okay. Then why do we care about this encoding or decoding? That's very related to our next topic. It's on data flow. And here in Martin's book, we talk about what is data flow. Data flow is that suppose you have different process, different server, different client. How do they exchange information, or how do they exchange data, exchange message? Martin mentioned that there are three main ways. The first one is a database. So database that abstraction is pretty simple. I believe that most of you should know is that you have some data, or you have some file you just store inside the data, and the database of course has some schema. It has certain API that support, and then for the other reader can go to the database and just fetch the result. So and then there are tons of details in how to practically use database, how to efficiently use that, how to make database distributed, and that's beyond today's talk. So let's focus on the next two. The second one is this is very interesting. It's called service call, and then the third one is called asynchronous message passing. So what's a service call? Service call is that you should think about that as a client server model. So I have a server, and then I have a client. So if you know TCP, then this has nothing to do with a TCP server or TCP client. So you should throw away that notion for now. Just focus on what we are saying here. So for server, then on this example, you should think about that. Suppose I have a web browser on your laptop, and then that's a client. And then here it's a server that's hosting data. For example, maybe Google, maybe your school website. Then this website, the web browser or native app, you will need to issue some task to the server, so that server knows that what do I so you send a query to the server, and then server will do some processing and then send the result back to the client, and this is called service call. Okay, so result. Then this turns out that very popular nowadays, because at the server, you should think about that server. In the old days, server has tons of different servers that you can process tons of things. But right now, we try to minimize the responsibility for each server, and then that's the origin of the so-called microservice, or sometimes we call it service-oriented architecture, because that the server here, it can also be a client to other service. So for example, like this, I have this as prime, I can do this. So this is also possible. And then microservice, so the way to think about that is that you have tons of different services, and then there's a certain architecture to connect all of them to make sure that the quality of service is good, to make sure it's reliable, maintainability, tons of different things. And then one example for service call, that kind of data flow method, is called REST. And then it's actually not protocol, it's a design philosophy. So the first thing is that you want data format to be very simple. So for example, like string file or integer. And then the way to query or to send your service is that you have a URL here. So how do I identify a query? So you may have a specific URL. So let's say that this is the service I want. So if you send a different URL to the server, then that's a different service. Okay, and then it must like support the HTTP feature. So for example, like cache control, authentication, and then this thing should be RESTful. Okay. And then there's another family of a service call, which is also very popular in distributed system. It's called RPC, which we will talk about that next. Okay. So now the third type of kind of data flow model is called asynchronous message passing. The idea is that I don't directly send a message to you. Instead, I send to a broker, and the broker will handle the message. And then it's similar to RPC, is that this latency is actually very short, very low. Then on the other hand, it's also similar to the database approach because you send a message to an intermediary. However, that it's unlike the database is that the reader doesn't need to kind of proactively go to database. Instead, the message broker will send a message to the other end. Okay, so here's an illustration. So I have a message broker, and then I have a kind of sender. I send a message to the message broker, and then message broker will be responsible to kind of forward the message to the receiver. However, if you look at the case for database, it's a little bit different. So I have a database here, and then I have a sender that send a message to database, and then a receiver actually need to go kind of as database, say that, hey, what's the data, so on and so forth. So the concept, even though it's very similar, but it's very different. Okay, so now let's look at a message broker, and actually it's a very powerful and popular design. So like this MB thing, the broker should most of the times implemented as a message queue, and queue is a very simple abstraction. So do you remember what's the property of the queue? The property of the queue is that first in, first out. Okay. So that if you insert this thing first, then this should be the first thing to pop out. And then usually that this abstraction is one-way communication. So the sender send the message broker to the receiver, but the sender will not expect the receiver to send back to a message back to the server. And then there are several advantages of all this abstraction. The first one is that this broker can serve as a buffer so that the sender will not overload in the receiver. And then the message broker can also re-deliver a message. So for suppose that the receiver moves to the other IP address or that it disappears, it come back up later, the message broker can redo the sending process. And then for the sender actually doesn't really care about that the information or the address of the receiver. It just tell a message broker, say, hey, here you go, whoever wants it, you should send that to them. And then it also supports a multicast or broadcast by LAN. Is that let me change the color, is that the send message can send to many different nodes at the same time. So all of this is the same message. Then the very powerful way is I logically decoupling the sender and receiver. For the sender, it only needs to focus on the sending. For the receiver, it only need to worry about the logic after receiving message. Okay, so the general framework, sender send to the message broker, and then usually like if you read like kind of practical article, this message broker will be specified as a topic. So you can think about them. Each message has a certain type. It specify that who are the receiver that might be interested in this kind of message. And then the broker will forward in the message to the receiver. And sometimes we also call this server as a producer. So you should think about maybe like kind of newspaper. So the server is a producer that kind of produce tons of content, and each content has a type topic. And then the receiver can be a consumer or subscriber because it will specify that, hey, I like this topic. For example, I like sports, I like the technology section, so on and so forth. And then the message broker will say, okay, Louis, you like it? I'll tag you. I'll send this topic to you. And then Joe, if you like this, I'll send this to you, so on and so forth. And sometimes we also call this a pub sub model because it's a publish and subscription model. And then why this is very useful, because oftentimes we have tons of source, and then that source need to we have tons of information source, and sometimes we need to redeliver this information to different components into the system. And oftentimes if you have this broker, it's very easy to use. That's kind of the central area that you can find out what type of message you need there. Okay, so that's that. And then there are tons of different message queue examples, message queue systems. And I think that if you look at top system conference, there are the still one or two like queue paper every year. So it's still very interesting research area. So we have Zero MQ, RabbitMQ, Kafka, MQTT, where MQTT is specialized for IoT, Internet of Things. And I would say that Kafka is one of the most popular solution because it's out there for a very long time. And it was originally developed by LinkedIn and picked up by many other big companies. And yeah, and if you want to really pick up some of the queuing service or like broker, and there are many interesting practical concerns. Yeah, it's maintainability, whether it's easy to use, or how about is it easy to deploy or develop? Does it support a nice ecosystem? Does it support tons of different services? And then also, of course, the compatibility issues, and then the performance, durability, and there are tons of them. And if you are interested in research, and this is one good area to enter to start with. You can just test all those systems and then design a benchmarking system to understand those issues. Okay, so that's all I want to talk about today. The takeaway is that what's encoding, what's decoding, why do we need them, and then three different data flow models. That's all. Thank you.